Hello.
Hi.
I thought you were doing well. I will be. Okay. The small word I gave you, I'm not sure if any of you. Right.
It's like you are watching. Yeah, I watch Joshua match.
I told you. Is it what?
Oh,
Over this week.
No. The guy is because of the land. But the guy is so sweet. It's very sweet. And it's a support, so you give him more richness. So the truth is Joshua is not. It's too gentle for both. All of them are relatively to 80. You can see endurance. But you're not that one. Yeah. You can see those times we up any. Yeah. My video was like about 2 or 3 television. Sometimes we use the fire. Early in the morning, yeah, it started from the Crystal Brothers. Yeah. And from there on coming. I don't think it's a living stand. I know whether the can whether you are. Yes. Anytime he's fighting somebody, it's a problem. And so, well, but the reason why was able to Touring has very footwears. Exactly. Footwears. Somebody doesn't have only footwears. It doesn't have a lot of footwears. I watched the match. It was Depending on the day. Yes, but it was close because one thing I realized, college you get a piece of it. So Joshua was trying to work on the body. Now, anytime Joshua was able to land little points on the body, the tail end of the round, the guy makes sure that he don't come in. It was difficult fight. It was very, very difficult fight.
I don't know. He's taking 75 million.
The guy is a technical fighter. Yeah, it's like 75 million. Oh, but they all get it. 35 million, 35 million.
Even the Ghana man who said he went to school. He was not for $1 million, and he just stood there. That's all Ghana. When they started the first one, the way he gave Pakayo some knock, I think, wow, okay, second round goal. He didn't throw anyone. Joshua Closet.
It's not serious. It's serious, but it's kind of watching.
No.
You have a chance. You have a chance against them.
The man was fixed. Now the particular match thing was fixed.
I have a chance.
But the face was good. They wanted to elevate Pakayo.
Yeah, no, I know we cannot keep.
Okay. So, personally, I believe that with a p-value of less than 0.05, those people have not been. And I believe that they want to be starting on. I will bring it up. I think that's not it.
Yeah, they want that. But I hope there will be another playground.
No.
Because this one was close. And try to pay for you.
I think we're legal.
So you know.
If you go to America and fight,
No, but we have won the fight.
With five guys fighting.
But on the night, oh, I'm going to count. Oh, you know.
I'll look for people.
Go down and
they were just using. They needed volunteers. So people like that, if they dress like military people, and then they take a picture of them, kind of put it on social media, everyone will say,
It's like Ghana says,
some of the money and contact the
if I don't be using the funds, the economy is better than this. And who was it? Oh, I can't hear me.
Alexander, some of
it's also Germany, France, everyone is giving them money. It's only China that is not giving them money. Right of them like you. All right. We have aligned the lady for long. Okay, let us do that. Yes.
I'm granted. I'm going to find out what's happening.
Hey, the chance to go, you are quiet like that. It was mine. You are making a lot of noise. So you are taking it for them when they are just in our corner. Yeah. This week, I spent a lot of effort. I will be surprised if Newcastle will beat City. And I will be surprised how many people. Very possible. Okay, please, I ask you to try. I don't know if anyone was able to do that. I respond. Okay. All right, so. All right, so far we've learned, please, those online, are we on? Can you hear us? All right.
Yeah.
Okay. So far we've learned how to compare a mean or average of a group to a constant. We've learned how to compare the averages of two groups being dependent or independent. We've learned how to assess the we've learned how to assess some of the assumptions about some of the tests, and we've learned that if the assumption, especially the normality assumption, is not satisfied, you have to choose a non-parametric counterpart. Yesterday, for the two independent samples, we learned that the non-parametric counterpart is the Mann-Whitney U-test. And we learned that for the paired samples t-test, the non-parametric counterpart is the Wilcoxon sign rank test, which we all learned how to do. Now we are continuing. What if you have more than two groups? What if you have more than two groups? So if you have more than two groups, we use a particular tool in statistics that is known as analysis of variance to compare the means. Analysis of variance, compare the means. So as I'm sure a lot of you who have done some research before, you have already heard the term ANOVA. So the term ANOVA, the full name is analysis of variance. Analysis of variance. Remember, when you talk about variance, we are talking about dispersion, spread. That's what variance is. Now, the question is, we are comparing means. So why not analysis of means, but rather analysis of variance? because obviously it has nothing to do with variance. So why is analysis of variance? Okay. Now I've written some hypothetical data for 3 groups on the board. Group A, if you can. Hold on, let me check it out here first. Okay. All right. So look at the 3 groups. There are 3 different groups. Look at the 3 groups. I want you to tell me, without doing any computation, do you think that the means of the 3 groups will be the same? Why? Why do you think you've not done any computation? Look at the various data sets. So for group A, you can see for group B, you can see, and then group C, you can see it. So without doing any computation, you think the means will be the same? Why? Why do you think the means will not be the same? The variance is too wide.
The variation, there's one issue and the column. The other one is and the column. The other one is and
Okay, cool. I mean, you said about that. The variance is entirely different. Okay. Okay. All right, but you were able to conclude by looking at it that the means are not the same because you did ANOVA there without knowing you've done ANOVA. Okay. What you did was you compared the variabilities between the groups. Yes. You look at how the observations vary between the groups and you realize that they were wide. And if you take how the values of group A vary or differently from that out of group B, it was large. And then if you compare that for group B to the group C, it was also large. So that is what made you come to the conclusion that it is likely that the means of the 3 groups will not be the same. Okay. Now I'm going to now do something here. So let's say now let me repeat the question. Do you think that the means of the 3 groups are the same or they are not the same? So it becomes difficult now.
Yes.
Because this time you realize that the variabilities between the groups have reduced. It is not like it was before. So how do we then use the variance to compare the means? We use the variance in comparing the mean by looking at how the observations vary between the groups as against within the groups. So at first we realize that for group A, they were basically closer to each other in the radius of 200. If you move to group B, they were closer to each other in the radius of 100. And then for the group C, it was in the radius of 80, 90, 70 there. But this time we realize that if you look at group C, the variability within has widened. So it becomes very difficult to now say whether the means will be the same or not. So whenever the variability across the groups or between the groups is larger than within the groups, it's likely the means will not be the same. It's likely the means will not be the same. So that hence the term ANOVA. So even though we are comparing means, we use the idea of dispersion. We use the idea of spread to compare the means. Okay. Now, the term ANOVA was actually coined by an English mathematician. And when he brought the ANOVA, when he brought this particular thing, he first applied it on agriculture data. So what he did was that he segregated plots of land into different portions. Then he applied some fertilizer onto the different portions of the fertilizer. And then he measured the yield and then wanted to compare the yield. For instance, if it's MPK fertilizer, maybe at least at one point, you wouldn't even apply anything at all, like the placebo. And then the next one will be some lower levels of the fertilizer, some medium level of fertilizer, and then some high level of the fertilizer. So because of that, most of the terms from ANOVA is also terms from agric. So for instance, the groups that I am talking about, call it the treatments. The group, we call it treatments. In most groups, we see treatment. When you get treatment, it's nothing. Basically, you're talking about that variable, that factor. So the levels in that group or the categories in that particular group, they call it levels, like I said. So the level, whether it is low, whether it is medium or high concentration. So when you take any test and then you are seeing treatment, you are seeing levels and all those things, that's the genesis of it. But of course, even though it started from agric, we have now don't even apply it to agric. And we don't apply it to agric only. So this time we have moved from there. Okay. So we basically use the ANOVA to compare the means of more than but you can use it. So remember, even the independent sample system that we are doing, you can use ANOVA for it. Anything more than one ANOVA, just that we want everyone to be in this game. So if we have to, it's better you use the independent sample system. If you won't get completing the law, you use the same thing. Whether you use independent sample system or use the ANOVA or you get the same. Now, in the ANOVA, there are several forms of ANOVA. So we have a case where we have one grouping variable. So for instance, in this case, I have ABC. Well, let me say education level. We want to compare life, like the life expectancy, the age at which people die across various education levels. You want to check if education is related to life expectancy. For those who have no formal education, you look at the various ages they die. Those who have basic education, the various ages they die, and so on. So these have several variables, several categories. So if you are comparing the means across one categorical variable with A levels, so more than 2 levels, we call it one-way ANOVA. One way, the one way because there's only one factor. There's only one factor that you are comparing the means across. Okay. We have two-way ANOVA. So in the case of the two-way ANOVA, remember the first example, I said education level. If I add gender to it, so this time I want to know whether gender and education level, I want to compare the life expectancy, the age that people die across gender and education level at the same time. So two categorical variables. So in this case, I will be able to compare the mean of males who have no formal education, maybe males who have basic education, to females who have no formal education. So that becomes two-way ANOVA. We have three-way ANOVA, which is our we are increasing it becomes more complex and complex. But we have K-way ANOVA. K-way ANOVA. The K-way ANOVA means that we have K levels, so too many levels to deal with. But we are going to concentrate on the one-way ANOVA. Taking baby steps. So one-way ANOVA. So like I said, in ANOVA, we basically compare the variabilities between the groups within the groups. So we denote the sum of squares. The sum of squares between the group by SSB. So when you see SSB, I'm not talking about the formal part. Or SSB, right? CSSB now, it's not NC. No, this is Société Générale. NC, but then there's been more. It's still there. Is the bank still there?
Now that is the name that they changed to.
That's the name I didn't see that bank. Anyway, so and then we have the SSW. The SSW, that one measures the sum of squares for the variability. We need the groups. So basically, what we do is that the total variability. Now, so why are we looking at the total variability? Let's go back to the 3 examples that are written there. If all of them have the same value, let's say group A is only 200, 200, 200, 200, group B 200, 200, 200, group C 200, 200, 200. There's no variability in the data. So there's a saying that statisticians won't exist if variance does not exist. If variance is 0, statistics will not exist. The statistical investigation begins when variance is greater than 0. So we will now investigate why maybe you eat the same food, probably sleep on the same bed, but you have different weights. Then we start in the investigation. Why? What is causing that? So that's where the variability comes in. So the total variability is the changes in the entire thing. Why is it that the values in group A is different from the values in group B and so on? What is causing that difference? Is it different from across the groups or within the groups? So that's where we say we partition it into the total variability is between the groups part and then within the groups part. If the between the group part is taking the chance share, it means that likely the means are not the same. If the within groups part is taking the chance part, it means that likely the means are not the same. The means are the same. I'm saying that the reason why we really want to compare the mean in the first place is that we realize that the observations for the groups are not the same. So that's the total variability we are talking about. So this time we want to see where are these differences coming from? Is it because of the different groups or within the groups they are different, the differences are there? I think so. If it is across the group that is taking a chunk of it, then it means that like we started, the means indeed are not the same. But if it is not that case, then it means that the means are likely to be the same, maybe because of something. Because of something.
Yes, I'm coming. Sorry. If you are basing on the example,
Yes.
within the column,
Yes.
some are longer than others.
Yes.
And then within the column themselves, the variability is the and within the group,
Yes.
you can see the variability. So let's assume that the first group,
Yes.
there's no variability.
Yes.
Second group, there is no none of it. But the third group, there is
It is so called for investigation.
variability.
So called for investigation. Why is it? Why is it so? Why is it that the first and the second group they don't have any investigation? They don't have any variability.
Follow up. Let's assume that the group A, the variability is there.
Yes.
But other groups, you don't have this.
You can put the
You
investigation.
say
The moment you see variability, it means that the cost of investigation. If they are all the same, then it means that probably whatever you're applying is it doesn't have any effects on it. Okay. All right. So please remember in ANOVA we have K groups. The K group we are looking at that. So the K is literally more than 2 or more. So when we are stating the hypothesis, the null hypothesis states that all the means for the K groups are the same. All the means are the same. So that's why you see that the mean for the first group is the same as the mean for the second group, and so on. So the alternative hypothesis is at least one of them is different. The alternative is not all of them are not the same. I think we just need one to be different from the rest, and then we have negated enough. So right now, if you want to check if maybe my null hypothesis is that you all have the same money in your pockets, that's my null hypothesis. The moment I get one person who has a different amount in the pocket, I have negated. I have negated it. So some people usually say the alternative, but the means are all not the same. That's not it. It is at least one of the means are different. Sorry. At least one of the means is different. Once we get that, means that you are okay. Okay. So just like the independent sample t-test, the assumptions of the independent sample t-test is the same as the one we have. So the normality, equality of variance, it is an extension of the independent sample t-test. The independent sample t-test is 2, and this one is more than 2. That's all. Everything about it is basically similar to the independent sample t-test. Okay, so when you run ANOVA, whenever you run ANOVA, something pops up, and that's what we use in actually making our. What pops up, we call it ANOVA table, analysis of variance table, and this is what the analysis of variance table is. Remember, we said we look at the variability between the groups and then within the groups. So what it does is that it looks at which part of it is coming from between the groups and which part is coming from within the groups. So at the end of the day, the MS, that's the mean square, that's the actual variance. So the MS is what we call the mean square between. The mean square between the variance for the group across the group, between the groups. And the variance across the variability as a result of the differences across the groups. And then the MSW, the rest are just things that help us compute what is needed there. Okay. Now, these things are variances. Remember, I told you that when you are comparing variances, because they are greater than the divided. I think. So for them, if you want to find the test statistic, you compare the variability across the groups to within the groups like we're doing here. So that's why we see us dividing the MSG by the MSW. But you don't really need this thing. I'm just trying to use this data to explain why the whole thing is ANOVA. Someone has asked me before. But we are comparing me, so why is it ANOVA? So that's where the term ANOVA is coming from. But so remember they are K groups. Remember they are K groups. So that's why you see for between with the degree of freedom. Remember yesterday I explained what degree of freedom is. That's why it came as 1. For the total, remember the total is with the end here, we're talking about the total number of observations. So here, for group A, there are how many observations? 3, 4. So 4 plus 5 plus 5, that is the total number. So if you combine everything, that's the total. So that's why it's n minus 1. Now the m minus k is because for each group, this one is within the groups. So if we are going to take the groups separately and then find the degrees of freedom. So for instance, in the first case, we are going to get 4 things. So that's 4 minus 1. Then the second one will be 5 minus 1. Then the third one will be 5 minus 1. So 4 minus 1 plus 5 minus 1 plus 5 minus 1. That would be 11 minus 3. Where this 11 is the total number and the 3 is the groups. So that's why the m minus k there. M is the total number of the division and the k is that. Okay. So let's now go to the next SPSS. So the data we are going to use is the popular tree. Oh, I'm sure you know what popular tree is. You have all your message. And that tree there, that is what the winter popular. So those things that they use to verify, it is actually it comes from them according. So basically, what they did was that they applied treatments to some parts of soil and then they planted popular tree. After that, they weed it, check which of them. But they wanted to check if the treatment actually has effect. So if you like, you can just go to the variable view and look at the treatments. And look at the values for the treatment. So you can see no treatment, so which means that there was a portion where they didn't apply any treatments. There's a portion where they applied fertilizer. There's a portion where they just irrigated it, they didn't add any fertilizer mix. And then there's a portion where they applied both fertilizer and irrigation. They wanted to now see if these things I mean, maybe it doesn't matter what you do, the rate will be the same. Also, if you can also check the sites. So they also, so we feel that we can use this data for 2 million watts. We are not going to do that. So they also segregated the plot or the land that they planted the tree on. One part of the land was rich and moist, and then the other one was sandy and dry. And so they wanted to check if maybe it could be that the treatment is not doing anything. It's actually the soil that is actually doing the good work. So sometimes when you're doing experiments, that's what we're doing. Okay, so if we want to compare the means, of course, you can start with your box plots. But I'm sure we already know how to do box plots. So let's move straight to the annual. Oh, you can do normality test. We want that to be normality.
I want to know the process.
Okay, necessary. Yes, it's necessary to do normality. But like I said, ANOVA is very robust. ANOVA is a robust statistical tool. So unless you draw the table, because the deviation is so huge, let's take the ANOVA. So you can basically draw your table box and then check and see. So let's try it and then draw our table box. Descriptives, table box. Okay, so table which is all right. Yes.
Yes, you look at the which.
Yeah, the which career rate by hour.
So let's do it within the groups. If you segregate it, let's go to graphs and see. Legacy data. Is it the legacy data? Yeah. No, it's not. Go to say make chart order. Fine, that's fine. Let's go to data notes. Data and then strings. Yeah, strings. So organize our by the piece. So organize our
Compare by groups.
yes. Okay, based on the piece. Like, that's very nice. Yes, sir. So this one for the individual one. So you can see that the deviation is not too huge. So we take it like that.
This is for no treatment.
Okay. You know, there are 4 groups. You can actually use that for anything. So for instance, let's go to compute me for several groups. You can use that option to actually do your analysis in the. So let's say you are in an organization, there are several departments, and you are doing some things. You don't want a situation where you do it for group A, then after that you go and move to do it for group B. It's the same thing. So basically it's like a looping version of SPSS. So what you do is that if you go to data, then you go to split file. You go to split file. So then you choose that group you want to do the analysis across. So in this case, we wanted to do it across the treatment. So you select the treatment and then you push it to you select compare groups. then you push it there, and then you go to work it. So whatever analysis you run from now on, you done separate for the various treatments. So it means that if you are going, you don't need it again, you have to go back and take it out. Otherwise, it will be there until you take it out. And it will be there until you go back and they analyze all cases, do not create. So this, now that we are going to do that, we have to go back and remove it. Otherwise, it's going to give us some error.
If you want to let it try. If you want to try,
Only try.
like,
You can split it as split in.
Yes.
no, you go to data.
We will do it again, because when we do that, we will come and split based on soil type and seed.
Oh, okay. They're going to split now. I'll go to.
Okay. So let's see. These are whatever analysis we are doing now. So we can now do the case for changes. Okay. All right. So now that you have done it, you are going to do the you go back and move it and reverse it. Go and choose the first option. Analyze. When you go back to the split bar, you go to choose the first case. Analyze all cases. Note. Okay. Please let me show. Let me show you something on SPSS that will make things easier for you. On the standard toolbar, can you point here the fifth item? Transform fifth, not the standard toolbar, not the middle. Fifth. Yes. So that's that particular. Look at the where the headlights on the board. So that's that particular icon. When you click on it, it shows you all the recent things that you have done. So for instance, you already done so far. You don't have to go and look for it again. Once you click on it, it will be the first thing that shows up there. So you just click on it and then you go back to where you go. Because sometimes it can be you wondering where did I even go? Where did I even do this? So once as soon as you click there, all the recent things that you've done will be there. Then you just choose the one that you go to. Okay. Now let's go back. Let's go and conduct our ANOVA. Let's go and conduct our ANOVA. Okay, so to conduct the ANOVA, you go to analyze. There are two ways of conducting ANOVA. In explain it, but you the same before, so you are just going to remember. I don't think we want to know that one. Analyze, compare means, and then one-way ANOVA. Analyze, compare means. Analyze, compare means one-way ANOVA. Analyze, compare means one-way ANOVA. Okay. So what you do is that you push the continuous variable, that is the variable you want to compare the mean, the dependent list. So in this case, weight. You select the weight and then push it to the dependent list. Select the weight and then push it to the dependent list. The next is the factor variable. So for the factor variable, you select the treatment. You select the treatment, put your cursor in the factor, or just go to the factor variable and push it there. Okay. Click on options. Then the next is you click on options. So in the options, I want you to select two things here. The first one is a descriptive. Of course, you need a descriptive before you can start talking about the test. So select descriptives and select homogeneity of variance test. Remember, we said it's also an assumption. We are assuming that the variance across all the groups are equal. That's also an assumption that we are making. All right. So we go to continuum. You go to continuum, and then you go to OK. You go to continuum, and then you go to OK. All right. So the first table is a table for descriptives, where the means, the standard deviations, the minimum, and then the number in each group, and of course the confidence interval for the mean for each group has been computed. So if you look at the means, the mean weight for the no treatment group is 0.6465 kilograms. For the fertilizer group is 0.655 kilograms. I think the fertilizer irrigation is the highest. Followed by the fertilizer, and then the no treatment, and then the irrigation. Look at the irrigation. It's actually worse than not adding any treatment to it at all. Okay. Then we move to the test of homogeneity of variance. Test of homogeneity of variance. Now we are going to use the one based on mean. But if you look at it, it doesn't even matter which one you use. But usually, because it's a parametric test, we use the base on the mean to reach our conclusion. So if we check there, you can see that the p-value is 0.146. 0.146. Remember, our law according there, just like we learned yesterday, that the variances are all equal. The variances are equal. So based on that p-value, what will be our decision? How will we decide? We are not going to reject. So it means that we are safe. I think we can proceed with the assumption of equality of variances. That is 14.6%. Obviously, more than even 10%. Then we move to our ANOVA. We move to our ANOVA. Now, when we come to ANOVA, you can see the table that I was describing is what has come out. ITB. So the source, you can see between groups, within groups, and then the total. So if you look at the mean square, you can see that the variance for between the groups is 2.675. That's the variance. When they computed the variance between the groups, that is 2.675. But within the groups, the variance is 0.34334. So that really tells you that it is likely that the mean will not be the same. It's likely that the mean will not be the same. So if you check the subsequent F value, the F value is basically when they divided the top by the down, the 2.675 by the 0.3. For that how they work. No one has to complete it in the. But the P value for the test is less than 0.001. So that also tells us that the means are not same. The data is providing evidence to suggest that the weight of the tree across the 4 treatments are not the same. They are not the same. So tests like ANOVA are generic tests. That is, they are in statistics we call it omnibus tests. Omnibus means they cover a lot. They don't go into specifics. I do. So if I come here and say, not all of you have the same money in your pockets. So who are those who are causing these differences? It could be that all of you have but one as the same. So it could be just one person that is causing all these differences. So when you are done with ANOVA and you conclude that the means are not the same, we do a follow-up test. And that follow-up test is, we call it a post hoc test. It's a Latin word, post hoc. It means after. It's like a follow-up after you've done the main test, something that you do to further investigate why you rejected the null hypothesis. So we call it a post hoc test. A post hoc test. Okay. So to do the post hoc test, to ascertain where the differences are coming from, we have to take them in twos. But there are several groups. We have to maybe take you and her, compare. And then if they are the same, we will move on to the next and so on and check where the differences are coming from. So to do the post hoc test, we go back to where we conducted ANOVA. So you can go to analyze this.
So the post hoc test, you do it only when
you reject it. Yes.
Now
you have to reject this.
Because
Because exactly, it means there's no need to further investigate. I mean, you already said they are all equal. So if there's no need to take one, I mean, I different from the rest. So to conduct the post hoc test, you go to, of course, analyze, compare means, or calculate that 2 bar that I show you, so that we take it down over straight away. Yes, to take it there straight away. This time you already selected everything. So what you do is that you click on the post hoc on the extreme left. After contrast, you see post hoc. After the contrast, you see post hoc. So there are a lot of post hoc tests. But the popular ones are the LS, the fishes, but it's a cake now. So yeah, has a lot of flaws. But that was the original one. The first who brought ANOVA in, that was what you brought. The first one had a least significant difference. That's the thing. Then we have the Bonferroni. Then we have the Sheffield. We have the Sheffield, and then we have the Tukey. The Tukey, but the popular ones are the Bonferroni and then the Tukey. The Tukis are two. Tuki is original one. The Tuki is someone who came to modify the other.
The LSD
It's the least significant difference. In fact, the Tukis one is actually HL, but I don't know why they didn't add it to HL. HL, that's honest significant difference. These are a lot of people are coming with all, but the ones on top are when the variances are the same. Remember when we tested that hypothesis, we considered that the variances are the same. So that's why I'm concentrating on the top part. If we had rejected that hypothesis, we have come down. Look at the down one. That's the Dunnett and then the Cummings sockets. So all these things, yeah, you have to be based on the initial test that you have done. So let's select the Tuki, the first Tuki. I just prepare the Tuki point. Even though the Bonferroni is also, but you can select as many as you want. Tuki, the LND and the Bonferroni.
Let me ask you.
Then we can also select Gabriel if you need an angel.
Waladankan. That's Waladankan too.
Yes, Waladankan. So it means that
And then
some of these tests, for instance, the Mann-Whitney test, another name for it is the Wilcoxon-Ransom test. Some of them like lecturer, professor. If the students did the work, the professor just and then they added their name to become like affiliated kind of thing. That's one of these things. It's a modified one. Some of this, when they bring it, then there's a little, oh, look at all this, we can throw this assumption away and use it. Anyway. Yeah, let's maintain the 0.05. That's what we use for the test. Okay, so we go to working. It's all. There's something that we call contract. That's for contract. That's for the agreement. Yes. But in the case of the contract, sometimes you want to use some specific, sometimes some theory saying let's say I have these 4 groups, and maybe a theory saying that if the average of these 3 people is the same as that person, so that one becomes a contrast. That one, because it's like we are taking 3 groups and comparing it to 1. Or if we multiply your average by 2, it's the same as multiplying this group average by 3. That one becomes a contract. So that's the contract. So that one is typical for that very good. Anyway, so we go to okay. The first one is the repetition of it starts from the multiple comparison. The first 3 or 4 tables are the one that you already explained. So then all the 3 that we selected are the ones that are, you can see here. Okay, so the Tukis is so let's start from the Tukis test. So of course, when it takes one, it will compare it with the rest, then move to the other and compare it with the rest and so on. So if you check the rows, you can see that there's no treatment. So it compares no treatment to fertilizer, to irrigation, and then to fertilizer irrigation. So if you compare the no treatment to the fertilizer, the first is the mean difference. The difference between the average weight for the no treatment and then the fertilizer weight. And you can see negative. Which means that obviously the fertilizer group had higher average weight compared to the no treatment. But the p-value for that particular difference is 1. It means that for the low treatment and the fertilizer, there is no significant difference between them. So that's not where the difference is coming from. That's not where the difference is coming from. Now we go to no treatment and irrigation. No treatment and irrigation. So that's the difference between the mean is 0.1095. But the p-value is 0.932. That's almost 1. So which means that that is also saying that the difference is not coming from that end. Then the last is the no treatment and the fertilizer and irrigation. For that, you have seen that there's asterisk on it. Any one that you see asterisk on it means that that one is a significant difference. That's why I say that I'll leave that for you. To me, that one of the differences is because of no treatment and the fertilizer irrigation. That's why we rejected the null hypothesis. Okay, that's one of them. Now we come to fertilizer. So for fertilizer and no treatment, we've already done that. So we don't need to do it again. But we did no treatment and fertilizer. It's the same thing.
But the observation I'm seeing here is that
Yes.
for the third one, the treatment of the
Yes.
but then it's very
Because it's the first one and the second one. So which means that the fertilizer average is greater than no treatment. So it is what they have reserved minus what they are comparing. But you can see that the same thing. Just that one is negative, one is positive. Okay. So for the fertilizer too, if you compare it to irrigation, you can see there's no significant difference because the p-value is 0.916. Fertilizer and irrigation. We already did no treatment and fertilizer. That's why I skipped that part. It is legal, it's like a repetition. And then fertilizer and irrigation, there's a significant difference between them. So which means that the fertilizer and irrigation seems to be because it has a significant difference with the no treatment and also has a significant difference for the fertilizer only. For irrigation, we can see that it's the same thing. Irrigation too do not have a significant difference with no treatment. It doesn't have significant difference with fertilizer, but it has a significant difference with the fertilizer and irrigation. Which is like basically it's one group that's causing all these differences, and that's the fertilizer and irrigation. If you take that one out, the rest will be have the same, or they have the same needs. The rest is basically irrigation. Now let's go to the other one. I think they also the same thing. They have the same conclusion. They have the same conclusion.
They put all of them together, so you can't really see that cost, not anything.
Yeah, I'm talking about LN. Oh, yeah, the first line they took it hard. So you can see that the HSB, they took it HSB. Wow. The HSB wasn't there. So that's what I was talking about. They took it HSB. It wasn't there, yes, yes. So that's honest, significant difference. I don't know why you say honest. Anyway, so then the last one is the comparison. The same conclusion for the comparison.
So for the
Yes. Yes, there are different methods. The people do not.
I think there's
Okay. Yes. Yes.
No treatment of private. There's no what is. That's more than they have. For the girl partners, for the girl partners. For the girl partners. The one that's going on, well, it's not a fight. It means no, it's a good time. It will be affected. You don't get
You don't reject it. Yes, but because of the error, we don't want to stick out our neck and say, it's just like just saying, based on the evidence, I will not do innocent, whatever I feel reports. Okay. Now, let's go and split the analysis into the sites. Let's split the analysis into the site as to the rich, the soil type that we use. So we are going to run this here analysis, but first we are going to split file. We are going to split file, data split file, or we can just click on that and then select split file. So data, go to data, or click on that and just click on it. So then you select split file. Okay, so this time select soil type. Soil type, and then choose the compare groups, and then push it on inside the compare groups. Then go to OK.
I think the percent of
Yes.
Who's
Okay, so now that we are done, let's go back to our arrow bar and then run the same thing. Everything is already there. So go to analyze, or you can just click on the menu bar. The standard bar. To analyze, compare means analyze, compare means one way ANOVA. So when you go there, you don't even have to select anything again. But you've done all the selection already. Unless you have done resets. Yeah, everything, yes. The weight is there, and then again the fixment, they are all there. So don't just go to working. Yeah, so you can now see that it has segregated the analysis into the various soil types. For the defeat, you can see that the rate and moist as on top, and then the sun is down. The ANOVA to the same thing. So you can see that the ANOVA, the differences in the means are no more significant for the sandy and dry. Look at the ANOVA table. For the rich and moist, the p-value is 0.003. For the rich and moist, the p-value is 0.003, which means that for the rich and moist, we will reject the null hypothesis of equality of means. So for the soil type that was rich and moist, there is a difference, or the means are not the same across the board. But when it comes to the sandy and dry, actually it's agreed data, so you can choose 10%. Yeah, this is agreed data. So like I was, you can choose 10%. But if we are maintaining our 5%, then for the sandy and dry, it is not significant. I mean, there's no significant difference between the okay. So if you come to the post-hoc test, after the post-hoc, it doesn't care. It will do it for you. We said it will do it. So it will do it for you anyway. So, but this time, when it comes, I think the same thing, right? It is. Yeah, it is a fertilizer irrigation that is still causing the yes.
Please, the attendance sheet is coming around. Please check your name. The same names we use for the certificates. So please check to make sure the spelling and then the arrangement is the way you want it. So that if there's any correction, please correct it and then we can fix it. Thank you.
Okay.
What is correct? You sign.
Okay, you sign it.
All right, so
Why not correct?
Look, we are taking that and the pressure on the same.
So instead of splitting the part, you can instead decide to do a two-way ANOVA. But this time there will be two factors: the soil type, the treatment. So that was in that case we are entering into a two-way ANOVA realm. A two-way ANOVA realm. But like I said, we are concentrating on one-way ANOVA. But we can also, before you even start analysis, you can draw a cost plot. You can draw a cost plot to even work your appetite to check whether even there are differences in the means at all. So let's go back to see how we draw our cost plots. So graph Charles Golder or Legacy Dialogue. Then you select box plots. Okay, so drag and drop it, yes. Choose the weight, put it to the Y, and then choose the treatments, and put it to the X.
So 3,000 something.
Why is it not time?
Sure.
Yeah, you wait.
Yes. The first one.
I need
Weight and treatment. So weight on the vertical, treatment on the horizontal.
So from the box plot, you can clearly see that the fertilizer and irrigation IATB is higher than the rest. So from there, you can even see that it's likely that the mean or the average for the fertilizer and then the irrigation will not necessarily be the same. You can add a soil type rate, like you can cluster it by the soil type. You go back to the first box. That graded. I wanted you to draw it up at no, then put it in the past. But you have to let them know how I did the problem. But you are so splitting the file. Please, if you have not taken that off, the split part of it will still be there. And so we have to go back to split part and then you have to go back to split part and then unsplit the part.
Okay, so we have to go back. So that we have to take it now.
Yeah, when you go to the you have to take or otherwise. So when you go to analyze, graphs. When you go to graphs, and then select the child field of that. So you choose the second good box ones.
Yes. There is only the second one. The
Second one, you drag and drop it. So you select the weight you're putting on the y-axis. You select the treatment and put it in the x-axis. And then select the soil. So the second one. But you can this one was so the soil. When you go to start go there, the box, choose the second option. Drag it and drop it.
That's why.
Yeah. Why is this side?
Chachi, I hope you're hungry.
Yes, that's it. Yeah.
I hope you're hungry. Or you want to
Change
eat? The man likes you to proper.
So you still have this place back. This one.
This one.
Yes. So go to data. You put your approach data. Okay, let me show you the shortcut.
No.
Check analyze by good idea, good.
Already done. Okay, you guys said how much? The second one. No, so don't do it, then. We should clear it, trust me. Please, those who are online, are you with us? No, it's not about, you see, sometimes I expect that maybe they will.
Please, those online, can you hear us?
If you are not hearing them, they literally take the money.
Hello.
Yes, yes.
Yeah, my line has been on and off, so it's like I couldn't follow clearly.
Oh, okay.
Please, which part?
Before you got here,
If you can be specific where you got to.
how was the split
Okay.
thing?
Yes. So what we are trying to say is, suppose you have another group that you want to compare your analysis or do the analysis across that group. That's when you use the split file option. And to do that, you go to data and then split file. So in our case, we wanted to compare it across the soil type. So we went to data split file. Then on the left side, you will see some options. The first option that has been selected is analyze all cases. Then the second option is compare groups. And then the third option is organize output by groups. So what you do is that you choose the compare groups option. Then you select the soil type and push it inside the groups based on. After that, you go to OK. So from there on, any analysis that you do will be separated according to the soil types. But when you are done, you have to go back and unsplit the file. Otherwise, if you are doing the analysis, it will continue splitting it according to whatever you selected. Okay. Those online, you are part of us. So if you want any question, you just let us know and we will address your concerns. So when you split the file and you conduct the ANOVA, you realize that this time the analysis has been done according to the various soil types. And that's where we are trying to so when you split the file and conduct the ANOVA, you realize that this time it has segregated it into the various soil types. So for the rich and moist, you can clearly see that at 5% level of significance, there is a significant difference among the average weight, I mean, for the four treatment groups. For the sandy and dry, however, there is no significant difference among the weights for the four groups. So we wanted to subsequently use box plots to explain, but the box plot has to precede all these things. And before you start the analysis, that the exploratory has to start with box plot and then the descriptive before you come to that over. So for the box plot, you have to go back and unsplit the file. Otherwise, you'll be getting two separate charts. So that's where you go back to the data split file, and you have to this time select the analyze all cases. Do not create groups. That's the first option, and then click OK before you draw your box. So after drawing that box plot, you can then see that the mean for the fertilizer, irrespective of the rest, whether it's a sandy, fertilizer irrigation, irrespective of whether it's a sandy or a rich and moist soil, it's still kind of higher than the rest. However, looks like for the sandy, the variability is too huge. Look at the box, it's too tall. So basically, the difference is actually coming from the fact that you planted the tree on a rich and moist soil, you fertilized and irrigated it. That's where the big thing is coming from.
The sandy, what does it look like?
I think that the variability in it is too deep. Obviously, this may obviously call for further investigation. All right. Now that's like what we are doing yesterday. If the normality assumption is violated too much, we have to resort to non-parametric counterparts. So in the case of comparing more than two averages, the non-parametric counterpart is the Kruskal-Wallis test. Kruskal-Wallis test. That's for the normality. There's the Kolmogorov-Smirnov, that's for the also normality. And this time we have, so that's the name, Kruskal-Wallis test. That's and yours is Shapiro. Someone I think already taken the Shapiro. You okay, we did what about the two? And then 50 and then it's from praying and then there are a lot of the names, and some of them we hear it. But it's their names. So unfortunately, we don't have a specific body test. Or every pattern we have access.
We follow we are always good.
People like Achampon-Lenz are treated now.
You see, the thing about this is that whether you want to accept it or there's an element of racism in it. That's true. In the science, it is very true. When you send you can ask this one, you can send your paper and they realize that so far is food. can't bring it. They will say they rejected it. Then they will send a right to you. Yes. IATV, they will send a right to you. You are your personal mail that give them the original thing and then they can see what they can do with it. Because they are going to put their names in front, and then you will be at the back there. As soon as they do that, it will be accepted. The same thing. The same thing. And I'm sure you also have to factor in the fact that those times slaves couldn't black, they couldn't own patents. So a lot of the things, the white, I mean, even now, last time I was watching CNN and some of the black companies now winning some of their patents back. But after that, they do the thing, discover, and then the white to take it, and they are enjoying it. So they are not giving them back to the black. So, I mean, this thing, it is structural or it's personal, you can never take it out.
I'm not that. But somebody like, I think somebody like I'm talking about former. So it's probably, I think one of the world renowned.
But this thing like this kind of thing is the 19th century and then the early 20th century.
Whatever that you are doing, is dependent on this one.
It's dependent on this one. Yes, dependent on this one. Last time I chanced on MIT, their entrance exam, I think for 1960 something. If you look at it, it's like BC. All the maths is like BC. And people are saying like this one, and all of the people have done it very easily. So I've done it easily, but they won't give you that the chance to even wait. It's been now. Even in South Africa, Dr. Menka, you were telling me in Stellenbosch, those times, Stellenbosch University, a black can finish his thesis, then they will give it to a white. Then the black will have to start again. Yes.
If I don't go far, when I went there recently, there's a guy, he has spent about 10 years in the PhD. Yes. Not because his work was rejected, the white man picked it and completed the same way.
The same thing.
And there are no majority.
In South Africa.
So just that was 2018. Just in 2018.
Yeah, that's 2018.
It was rejected, someone picked it, and then just the color and change the result.
Breaking things. They will look at it and then you can't do that.
And so once it has been rejected, you start something new.
No, they are on top. They are the ones on top. If they say you are not going, you are not going. We are not certified. Yeah, that's the thing. So the fiscal wallet is the non-parametric counterpart of the 1B non-parametric counterpart of the 1B. So just like the other hypothesis, just like the other non-parametric hypothesis, the fiscal wallet is on the medians. It's on the median because of the fact that it has deviated from the normal, so we can't use the means again. So if you look at the hypothesis of the fiscal wallet, it is basically on the median. So the now hypothesis is that the medians of all the groups are the same, and the alternative hypothesis, of course, is that at least there's one median that is different from the rest. The assumptions are the fact that the variable that we are comparing the mean is continuous, it's independent, and there are no external confounders. I'll explain what external confounders are. If they are external confounders, for the ANOVA, we move to what we call ANCOVA. Yes, but we are not doing that. So, for instance, if there is something that is externally affecting the weight, there is something, another continuous variable that can externally affect the weight, and you can measure it, you can add it weight, and becomes ANCOVA. Like ANCOVA, that is analysis of covariance. It's no more analysis of variance, but analysis of covariance. So for instance, if maybe usually the simplest example I can usually are the ones in the hospital. Let's say you want to check the effects of maybe some doses of a particular drug of antibiotic on wound, how fast it heals the wound. But this thing, and we are going to measure it based on the time. So we are going to compare for each of them. So we take a particular antibiotic, you give for some group, you don't give antibiotic at all. For some group, you just give some low doses of it, you give medium doses of it, and then a higher doses of it. So those are your levels. But of course, another thing that can affect the other things that can affect the healing, namely the size of the wound. The size of the wound. So if you measure the size of the wound and then attach it to this, you can't come over. Even though your major aim is to look at the extent how fast it will move, but because you are factoring the size of the wound, you can't come over. So I'm just trying to say that some of these assumptions, someone brought them and someone said, "Oh, what? Let me clear this assumption out. What can I do with it?" That's how these scientific things come in. There are cases where you don't make any assumption at all. People that they clear all the assumptions away, and then they are doing that. But of course, when they clear all the assumptions away, they have its own restrictions. Okay. Okay. So let's now move to the SPSS and compare our list. Of course, there's also another one similar to Mr. Wallace, that's the median test. But the median test is weaker. Mr. Wallace is more powerful than the median. Why is that even more? We have the table.
And then it's split. So when yes, because one you want to split it. It's this way.
But it still doesn't matter. SPSS ignores these things. So anyway, so we're going to analyze. You go to non-parametric tests. Analyze non-parametric tests. Then you choose K independent samples. K independent samples. Analyze non-parametric. Legacy dialogues. Legacy dialogues. K independent samples. Analyze non-parametric tests. Legacy dialogues. K independent samples. We select that. The selection is basically the same as that of Hanover. So we select the weights. Select the weights and so this one, there's a difference here. So you select the weight and put it in the test variable. You select the treatment and put it in the booking variable. But in this case, you have to identify the range of the course that you are comparing. So if you go back and check the what do you call it, the treatment, you can see that we have assigned codes 1, 2, 3, 4 traits. ITV. So after selecting the group variable, you have to click on the define groups. You have to click on the define groups. Define range, sorry, define range. Define range. So you put 1 in the minimum. Okay, so let me start again. Analyze non-parametric tests, legacy dialogue, in independent sample. You select the weight and put it in the test variable. Then select the treatments and put it in the booking variable. After that, choose define groups. Define groups. Sorry. Define range. the independent limited. So let's finish, then we come interpret. Okay, so then you go to continue. So the minimum should be 1 and the maximum should be 4. So it means that if you have a particular variable with several groups, like I said, for instance, a region, you can decide to choose, but you have to conjugate. You have to conjugate. Maybe if you want to do something, that will be a lot. So maybe from 8 to 4, or 12 to 16, or 10 to 14, you can do that. These are you are choosing to compare those specific groups. Okay. Then for the test type, make sure that the Puska-Wallis H has been selected. There's the median test and then the John Cherry test practice today. But we are using the Puska-Wallis. The John Cherry too, also that's the same thing. Then you go to okay. Remember, you can go to options and select this, but you already know it. You don't have to bother with our. Okay. So if you check here, you can see that the Puska-Wallis test, the test statistic is 15.431, and the p-value is 0.001. So obviously, just like the ANOVA, they are rejecting the analysis. Unfortunately, SPSS is unable to do the post-hoc for the Puska-Wallis. So there's a post-hoc for Puska-Wallis. When you reject the analysis, another post-hoc it. But SPSS cannot. So by the time you know, I will download some Excel. There's something, but it's you have to buy it. But I think there is a trial, we call it Excel stats. You can download it and use it. I mean, you can do that for you. In Excel, it's a what do you call it? An add-on in Excel. We call it XL. So XL and stats. You want to go as soon as you call it, you will monitoring between this and do that. If I can do all the things that we are doing. XL stats. XL. No, X
for size.
X for that. L size. No, there shouldn't be a space. Right, when the software came, it was 3 months free trade. Now they've reduced it to 14. When it came fresh, it was 3 months. It was 3 months free trial. Money is coming, so they've tightened their. But it's cheaper compared to the other. I think it's $50 or something. It has the same everything. Independent. So,
all right, please, so we can take a short break. So please, those online, we are going for about 30-minute break and then we'll come back. You can also go to
all right, so those online, we are back. So I'm sure you're also back. Can you hear us?
There's only one person online at the moment.
All right. So we started our journey with what is entailed in hypothesis testing, the various components of it. And we said that we are focusing our attention on claims about averages. There are other claims that you can make. For instance, you can test proportion, you can test for independence where you use the chi-square and so on. You can test relationship between where you use correlation and regression, which we discuss next week. So, but our focus was on averages, comparing averages. So we started our journey with comparing average of a group to a constant. And in that case, you have to ensure that the normality assumption has been validated. And in that instance, use the one sample t-test. For comparison between two independent groups, if the normality assumption is not validated, use the independent sample t-test. If the normality assumption is validated, you use the Mann-Whitney Q test. The Mann-Whitney Q test for the independent, comparing two independent averages of two independent groups. Now, if the groups are paired, that is, they are dependent, they are correlated, they are related. For instance, in break-post experiment, before after experiment, or test the subjects that are naturally paired, we use what we call the paired sample t-test if the normality assumption is not valid. If the normality assumption, however, is validated for the comparing averages of two paired groups, we use the Wilcoxon sign rank test. Wilcoxon sign rank test. If you have more than two groups, and you want to compare the means across these groups, what is that one factor? We use the one-way analysis of variance, which is the number. If the normality assumptions are not validated, and if the normality assumptions are validated, use the Kruskal-Wallis test. The Kruskal-Wallis test. Now, talking about validation of assumption, for checking whether the data is normal or not, you can graphically use the kill plot, quantile by quantile plot. So in the quantile by quantile plot, you always see a reference line. The idea is to ensure that the points are not deviated too much from that reference line. So once the points are around that line, you can proceed with the assumption that the data is normal. Apart from that, if you want to use a formal test to check normality, that is where you go into use the Shapiro-Wilk test. The Shapiro-Wilk test. Of course, the Kolmogorov also does that, but as I said, the Shapiro is more powerful than the Kolmogorov memo. So you usually use that. Okay. Kolmogorov is a Then, if you want to compare variances, for instance, in independent samples, you need to compare variances because there's assumption of equality of variances. So in that case, that's where we use the Levine test. The Levine test. The Levine test will help you compare, check whether the variances of the two groups or traits are homogeneous. They are homogeneous. In the case of ANOVA, if you reject the null hypothesis of equality of variance, you sometimes be required to do a follow-up test. check where these differences are coming from. So in doing the follow-up test, that's where we mentioned that we can use the Fisher's LSD, the Tukey's HSD, or the Bonfereni, the Sheffield, the Duncan, the Waller Duncan, and so on. I mean, there are many. But the common ones, like I said, are the Fisher's LSD, the Tukey's HSD, and the Bonfereni. If you are comparing means of more than 3 groups and it is not normal, then you use the Stawalis test. Now, when we are doing independent sample, you realize that the output gives you 2 rows. A row for when the variances are equal, and another row for when the variances are not equal. When the variances are not equal, it has a special name. I didn't mention it, but it's still under the same table. We call it the Welch test. But I mean, you don't go through another method to generate it. But that second row, for someone who added it with, it is known as the Welch. WELCH. The Welch test for the non-equality of the variance. So that's what we have done in a nutshell. But there are others. For instance, if you are testing means and the external compounders, if you want to compare means and the external compounders, that's where I said you do ANCOVA. That one we will discuss it. Even in the case of the comparison of means, there are situations where the continuous variable can be 2. You can be comparing means of 2 different variables at the same time. For instance, in the case of a popular tree, instead of the weight, you can add the height weight. So, but the weight and the height will also be related. So we are comparing the weight, the averages across the weight and across the height over the treatment. So in that case, we are entering into the maneuver. We call it multivariate analysis of variance. That's maneuver. Now, when we take a paired sample t-test, we said they are for repeated measurements. So before, after. But there are cases where in between you take measurements. So even though you are doing the thing before and then there's after, but you do measurements, especially in physiotherapy. Sometimes they do some exercise, maybe they want to check how the person's reflex for people recovering from stroke. They go to the physiotherapy and then you check their reflex. So at any point, maybe every week, they will take how their reflex is and so on. Sometimes one professor at Kolebu, I was working with him, you take the person underwater and then you measure something. Or yes, I mean, they have their things that they were using. Yeah, but they were doing it over time. It could be in children. Maybe they want to take their motor sense. And some of their motor development. So they will do it weekly for some time. So in this case, you can see that it's not 2. It is several times. So which means that you are comparing means for more than 2 groups, but these groups are all related. They are repeated measurements. So it's the same person. Because the same person, obviously they are related. So in that case, that's where we call it repeated measures ANOVA. Repeated measures ANOVA. That one is not talk about it. So all these things are there. That's you can see, yes.
I heard you say that when you are dealing with ANOVA, usually
yes, for the non-parametric tests. Yes. For all non-parametric tests, we test on median, not mean. Okay.
So why do you not use
Okay. The reason why we use the medians for the non-parametric is that the means, means are very sensitive to normality, that is sensitive to data. So the moment you cross to the non-parametric zone means that the normality has been violated. So using the mean is problematic. The median is more robust compared to the mean. I wanted to show you how the software, the Excel stacks looks like. That you can do all these things in the that's very boring as well. SPSS is quite expensive. And SS is also very friendly. When people open Excel, they feel quite comfortable that opening another software. Yes. So
Go over the quality associates.
This part is defined. So if a data violates the normality assumption, remember there are several tests that you can do. You can just use the table plot and then say you are okay, but you can justify it that it's not. You can also go into the realm of the Shapiro test. Right? But in the case of the normality, remember that the null hypothesis is that it is normal. So if you get a bigger p-value, have to but the p-value is bigger, which means that you have more violated. Yes, it is one of the tests that you always pray that you don't reject the null hypothesis, because the null hypothesis is that it is not evidence based. Yes. No, I'm not ready. If I have to use another calculation. I don't drop down anything. Just click account.
This one.
You are making that move.
Let the bracket crack.
I don't have any family brothers.
I'm getting the pathway.
Anyway. Take that down.
Up to 80. So,
Yeah.
Of the
Exhaustion.
okay.
And it's working. I also have a 38 kilos. But I don't have it here. It's not
Let me clean up.
Yes.
I think they do otherwise.
Yes. What announcement do I have?
Announcement to hold the appreciate as a very by Saturday. No, Sunday. But with the man that's the man mistake. No one. I can lead operations. Keep me a man, I will do what. We need to once you pay them, they don't come at rest. I want to okay, you go, you put them. You look at where the ambassadors. No, so maybe so far so good. I must go along with us. No problem. Yes, go and show to our wives. Which okay.
Okay, so we have it running. So we have it running. So yeah, we just use our new. So if once you are done installing it, I think there's even an arrow. The photo there's like a link between one and the other. But if you want to test out, all you have to do is go to test hypothesis. And then the various hypotheses are there. So we have parametric test. So when again you can say one sample t-test, two sample t-test. Then we have a sample comparison of variance and so on. If you go to the non-parametric test, if you go to the non-parametric test, you can see that we have the various so one sample represents time run test. So in this case, you can do the one sample case for you. Then we have comparison of two. That is the Mann-Whitney test, the represents time run. Then the comparison of K, Muscawallis, and then the Friedman. The Friedman is for the PET, like with the repeated measurements. So when you the repeated measurement over that I said it's non-parametric is the Friedman. So these are all then we have the page test. Use the page test for compare variance. The McNeema, the Cochran and Marshall-Hensel, that one we should compare observation.
So let's use some of the data. One of the data is the Cochran.
Oh, it's simple, just like entering Excel. So we can just copy it. We can open it. Just go to SPSS. And then let's export this to Excel. What is it? The popular one, popular, the popular.
Okay, the body.
The popular one. I have to clear this with this. The original data is there, right? So you can open the original data.
Okay.
Okay, so let me go.
You can export it. All you have to do is SPS, you go to file, and then you go to export, then you go to Excel. Yeah, that's all. So in SPS, you can just export it to Excel. But use no. Otherwise, it will give you some. So select the Excel type. Go up. This one. No, Excel. The Excel. Okay, it has only up to 2010. Okay, fine. That's fine. So we've done it.
Yeah, let's check. Where did you go?
Yeah, that's it. That's it. So,
Start.
yes, it's up.
Okay, so here.
Open it was. Can you change this? Go back to SPSS.
So I will change it to.
Change it. Yes. So that it will. I want this in this format. So that it won't be posted. Those things won't be posted to be specific. So like,
I think.
so the same.
I will start that some.
Use the same version. Excellent. No. So write save value labels. No, so come here and save value labels where you find instead of about 6. No, can write the variable names file.
What of the labels?
The labels. I can see.
Cannot get a big. Yeah, okay, now we have it.
So we have it now.
So what I could.
So we go to if you go to the Excel stats and you go to test hypothesis. So let's go to non-parametric test. And then let's choose comparison of key sample here. Okay. So the sample, we select the what do you call it? Yeah, the weight. But we have to yes. You have to select everything, yes.
So I add the
Yes, yes, you have to make it that.
Okay. We should add a name.
Yes, add a name,
Yeah, I add it.
yes.
The part with the now, everything.
I think,
There's a part that is now, or up to them.
no, up to the, I think the now should usually have come.
I have cleared mine now. You have to clear yours
Okay.
before you just speak. Now,
Yeah, but in this case, because we have our data is a long data, we have to go to data format. You don't have to choose the first samples. You have to choose one column, no, one column per variable, right? Yeah, one column per variable.
Okay.
Not per sample, no, yeah, per variable. Yes. Then we now do got the sample identifier. That's like the package, the grouping variable. So yes, the treatment. Yes. So, so you can see that in this case, you can have multiple pairwise comparison. So go down. I think the popular one is the popular one. Forgetting the name. Yeah, the Canova. The Canova one is the very popular.
I've done it.
It's a very popular one, and they use the popularity correction for it. So you can go to options for the tax, and then change the significance level if you want. Okay. Then you can go to the output, like the things that you want it to come out. So we have descriptive statistics, detailed results, and a summary table. Then you can go to chart in case you want it to do some chart for you. So you can go to comparison chart and take box plots. So it means that whatever output is coming, it will include the box plot. So you can ask it to show the p-values on the inside on the box plot. So that from the box plot you can decide just Then we go to okay. Yes, we will continue. So the first one is the summary statistics, just like the SPSS case. So these are the minimum, maximum, mean, standard deviation for them. Yes. Go down. Yes.
I keep seeing on there.
Yes.
Even with the hypothesis.
So it has been interpreted something small for you. So you can the HA is a sample come from the same population. The samples do not come from the same population. So you do Excel in another clinic. Then
That's why they give the full sample of everything.
yeah, go down. There's more. So these are the multiple comparisons, and then these are the p-values. Tells you, so it tells you which one are significant. So you can see the fertilizer against the rest are significant.
Fertilizer and then irrigation.
Yes.
The significant one are the red
All
one.
are red ones here.
They were indicating, no, Bakela. Even the stress is so.
It's not easy getting this software too. That's why I know for instance it's difficult to do SAS training, SAS, but it's very expensive.
Let's say.
Yes.
Let's see it.
SAS, yes.
Is it?
So I think go to US, that's what they require, like they use a lot. But it's very expensive. So if you are asking people to come and for training, it means it's like you buy it for them and it's in thousands of dollars. So that's why it's expensive.
But we don't have like some kind of it.
What
They didn't be out.
so for instance, this one is a 14-day. If this exercise is 14 days, so if you have started using it, you have expired by now. So sometimes you also have to understand that's the way that everyone can get it. And this one is so restricted. There's even one that we call stars graphics. That one will be that's similar thing like it, but it's also very expensive.
That's like
Stars graphics.
that's the normally.
SPSS. Oh, you that. Yeah, excess tax. That's everything. Yes, that's everything. You can do the KK plot and all those things. So, sorry, what was go to the menu and let me. The menu. No, yeah, the menu there. The Excel staff menu. Extreme left. Extreme left. Red. The red, the three red line. Okay. Okay, so go to the discover, explain, and predict. I've not used. I have an older version, so that the interface is quite different. So visualizing data. You can go to visualizing data. Yes, and then all the plots that is on that are there. Visualizing data. Yes.
So which one should we click on?
Yeah, but that is a serious challenge. The PhD level is fine, but not the thing should be even an undergraduate level. But here in the case you go to a class and someone will tell you that's not a laptop. And the problem is also, the problem is that I think our politicians they want power so much that sometimes when you want to solve something, but there was a time last 2 years, University of Ghana wanted to add some amount to their fees. And that was to buy laptops for them. Yes, so me for the 4 years, you pay for it. When you, as soon as you are admitted, then they give you the laptop. And then Parliament's objected is that they are increasing fees to make the government unpopular and blah blah blah. So they shouldn't increase it. And what can you do? That would do the same thing. And they also say that, oh, we are 2019. Yeah, we are going to elections. People use it to campaign against us. You don't agree.
But the idea is fine.
Some of these things, some of these policies, some of the benefits are not coming to them. They will ask you, where are you procuring it from? And they procure it for you. That's not
You said you have a crack. In that comment, we use.
Actually, we know they need to buy another laptop for us. They are not competent.
Somebody's for
the quality is there.
the address of any investing.
Yes. What did it categorical? But you didn't type but that's what I was told. I was told that I want to become already. Probably, okay, so maybe next week, you can, I can,
Yeah, you can chip it into it.
well, regression and correlation about relationships.
Yeah.
So you can just chip in the kind of way that's for relationships.
We thought it has been covered in the previous.
Yeah, because it sent a slide and they were in there.
Yeah.
In there, so I thought so that. So next week, when you are discussing relationships, catching for you know, you take a legal and the kind of. But you can do the kind step here anyway, when you go to the test. And then you go to the non-parametric. Correlation association test. Correlation association test, yes. So that's where you can test for test on contingent tables. Kind
What did you do?
Correlation and association test, that is if in case you want to use. I'm talking about the using the Excel card. I don't use the SPSS, that one is different. You have to go to analyze and then what you call descriptive statistics. And then
Chi-square is somewhere there.
clusters. Here. Now go to statistics and then you take the time. That's how it
Correlation association.
I'm saying that for the on the SPSS, if you want to do the chi-square test, that one you have to go to analyze the descriptive statistics and clusters. Obviously, in your data, if you know it has the rule, it's in a tabular form. The chi-square test, what you have to do a nominal or the ordinal. So if people are maybe gender against education level. In the you see row and column. So which whatever the row variable is to the rows, whichever the column variable is to the columns, they are clusters. Then after that you click on the statistics. You click on the statistics, and then you make sure that you have take the chi-square. That's all. The rest, because you are not really doing chi-square, I don't want us to waste time. So no, we are not talking. So we can push maybe the year or the soil to the row and then one into the column. And after I go to the statistics.
Is it possible to be able to get my job?
So, those online, is we have ended officially. So hopefully we'll continue next week.
I don't know. I don't know.
If you mean you want to stop and you go back to the normal. One, two, then some of the time you guys say they don't have computers, and the right time you do the whole thing.
Because somebody told me that other people didn't go to admission.
I think if you see, you going to spend far on it.
You don't know where people are coming from. So that is the. If you are comedy, when you do with them, you don't have I don't think